Assalamualaikum and hello everyone. The next subtopic we are going to learn is 3.7 electrical energy and power. So we are going to look at the difference between energy and power. Okay, first of all, let's say we have a bulb here with different power rating. So satu 20 watt, satu lagi 8 watt. But they both are connected to the same value of power supply, which is 10 volt. So when they are connected, electron will flow throughout the circuit and the bulb will be light up. So bulb ni akan on lah. But since they have different power, right? So different power, which bulb do you think will have a higher brightness? Is it this one or this one? Since they both have a constant power supply voltage which is 10 volt. Okay, so obviously the one with higher power meaning that they have higher brightness. So higher power have higher brightness. But why? Actually power ni dia measure apa sebenarnya? Okay, in simple terms, power measure how fast electron can flow to the electrical device in every second. So higher power meaning that electron is moving faster. So that one is for power. Okay, now we look at electrical energy. Energy pula adalah accumulation of power over a period of time. Or in simple terms, how many electrons flow over a period of time. So let's say just now, okay, these two bulbs, we leave it on for 1 hour. Okay, biarkan hidup selama sejam. So within that 1 hour, we want to calculate, okay, how many electrons flow. So how many electrons flow meaning that we calculate the energy. So the amount of electricity used in an hour is actually equal to energy. Okay, so boleh nampakkan perbezaan dekat sana. So energy, how many electrons flow, and power pula, how fast electron can flow. Okay, now we look at the formula for energy. So energy is actually the same with the work done. Okay, work done is equal to Q times with the V, charge times with the voltage. So since charge adalah sama dengan IT, okay, boleh substitute IT ni masuk ke sini. So we will get work done is equal to IVT. Okay, current times with the voltage times with the time. So meaning that energy juga adalah sama dengan IVT with the SI unit joule. Okay, that one is for the energy punya formula. Now we look at the electrical power. Okay, the formula for electrical power. Okay, since by definition, power ni adalah energy liberated per unit time in electrical device. Which means power is equal to energy per unit time. And since energy tadi adalah IVT kan, and then divided by T, so dekat sini dia akan cancel. So power akan sama dengan IV, which is why kita dapat the first formula. Okay, since V adalah sama dengan IR, so that one is for the Ohm's law. So when we substitute this one to here, we will get the second formula, I square over R. And then the third formula is you just change lah I square ni kepada I square kepada V square over R square. So you will get this one. Okay, and the SI unit for power will be watt ataupun simbol dia W. Okay, now we look at the energy dissipated in a circuit. So in a circuit, we usually have a battery, and then this battery will have an internal resistance, and they are connected to a resistor. So resistor dekat sini adalah usually will be electrical devices lah. Electrical devices can be smartphone, laptop, bulb. Okay, anything yang akan kita gunakan resistor. Okay. Now, if the question asks, what is the energy dissipated by the cell? Which means by the battery. Maksudnya kita mau calculate energy dekat sini sahaja, dekat area battery ni. So, it will be equal to I times with the voltage loss in the battery times with the time. So I dia akan sama because it is a series circuit. So I ni akan sama, but VB here will be equal to the voltage loss in the battery, which is equal to I times with the internal resistance. And then here, if we want to calculate the energy dissipated by the resistor or by the external circuit or by the electrical device. So dekat sini adalah electrical device. So meaning that it will be equal to I times with the voltage loss in the circuit, which is equal to I times with the R times with the T. Okay, so kedua-duanya ni kita akan dapat I square RT. Here will be I square RT. Okay. Now, if the question asks, what is the total energy dissipated? So, kalau total, maksudnya kita kena tambah lah energy dissipated in the battery and energy dissipated in the resistor. Okay, since here, dia adalah total kan? Which means, total dekat sini, we know that EMF is actually the total of VB plus VR. Okay, sebelum ni Miss ada explain kan dekat previous video untuk 3.4. EMF is equal to voltage loss in the battery plus with the voltage loss in the circuit. So, meaning that here, kita boleh simplifikan, the total of energy will be equal to EMF times with the I times with the T. Okay, so depending on the question punya information lah, which one we are going to use. Either kamu boleh terus masukkan this one if the EMF is given lah. If it's not given, so you need to find each of these first and then just tambah. So this one you will use this formula to answer the tutorial question later. Okay, so for the example, I'm going to discuss in the next video. Alright, so that is all for 3.7. Thank you.